A chemical reaction describes what's happening, a chemical change, if you will, that's happening. It always has the similar format. You always have reactants. This can be one or more chemical species. We draw an arrow to indicate the reaction is happening, and then we list our products. The products can be one or more chemical species. A reaction written correctly has to be balanced, which means there needs to be the same number of atoms of each type on each side. And the skill of balancing a reaction just takes practice. There are some tips and some tricks and some shortcuts and some things that you pick up along the way, but the bottom line is that you do need to practice balancing reactions. Let's go over a couple of them. I'll talk you through how they're balanced. And again, the bottom line is you're just going to have to practice them. Alright, for the first reaction, let's look at the reaction between hydrogen and oxygen to form water. When I write these out for my scratch work, I always leave a little bit of space before each of the chemical species, because I know I'm going to be adding reaction coefficients to them. Basically, I just jump in and I balance. I pick an element, and I almost always start with the very first species listed, the first element listed. So let's start with hydrogen. There are 2 hydrogens on this side and 2 hydrogens on this side, and so my hydrogens are balanced. Sometimes it is that easy. That would be the same thing as saying there is 1 H2 and 1 H2O. Then I go on to my next element. My next element is oxygen. There are 2 oxygens on the left, but there's only 1 oxygen on the right as far as the formula of water. I would never, ever, ever change the subscript of an element listed in a chemical reaction. That's not how we balance. We never, never, never change subscripts. Instead, we make more than one of the elemental species. Since I need 2 oxygens, I'm going to change this one to a 2. That literally means H2O plus another H2O. So do you see my 2 oxygens? And now my oxygens are balanced with only one of these. Now, of course, the problem is that when I made 2 oxygens, I also doubled the hydrogens, and so now I have 4 hydrogens. Hydrogens don't balance anymore. 2 times 2 waters, that gives me 4 hydrogens, and so I'm going to change this to a 2. And so my final balanced reaction is 2H2 plus 1 oxygen, I don't have to write the 1, yields 2 H2O. So just back and forth, back and forth, back and forth. Let's do another example. Alright, this is the reaction for the combustion of methane. CH4 is methane. The combustion of means the reaction with oxygen. For all complete combustion processes that involve hydrocarbons, I get CO2 and water as my products. The first reaction we had was also a combustion, but the combustion of hydrogen only forms water. Alright, again, just jump in, pick an element, and start balancing. I'm going to pick carbon to start with, 1 and 1. See how easy that is. Now I'm left with hydrogens and oxygens to balance. And as you inspect this reaction, can you see that one of these elements is definitely going to be easier to balance than the other? In this case, here are my hydrogens, and here are my oxygens. Notice that oxygen shows up in 2 different places here on the right-hand side of the arrow. That makes it harder to balance. And anything that's difficult to balance, you want to save for last. Essentially what usually ends up happening is that the hard ones to balance end up getting balanced before you're finished. By balancing the easy ones, often the hard ones get balanced in the process. Sometimes they don't, but often that's the case, so you always want to save the hard ones for last. If you run into an element that is difficult to balance, you want to skip it and move on to something else and balance something else first. And then go back and forth until you get the entire reaction balanced, like we saw in the first one. So 4 hydrogens on the left. To make 4 hydrogens on the right, I would need 2 H2Os. Again, that's like an H2O plus an H2O, so do you see my 4 hydrogens? Carbons are still balanced. I've now balanced the hydrogens. Let's balance the oxygens. I have 2 oxygens on the left, and on the right I have these 2 plus another 2. 2 waters give me 2 more oxygens. That's 4 oxygens, and so the 2 right here will then balance this reaction. Let's try another one. This is also a combustion reaction, but this is methanol. This is the combustion of methanol. And you'll notice, or you may notice right off the bat, I've got oxygen in 4 different places in this reaction. 2 places on the left, 2 places on the right. That's going to make it difficult to balance, so I do want to save it for last. I'm going to start in with my carbons, which are balanced. See how easy that is. Now I'm going to go to hydrogens. For my hydrogens, I do have 4 hydrogens in this one molecule on the left. To make 4 hydrogens on the right, I need a 2 in front of my water. Now I have 2 oxygens here and another 2 there. I have 4 oxygens on the right. I have 3 oxygens on the left. The oxygen here and here. This is an odd number on the left. I have an odd number on one side of the arrow and even number on the other side. We actually run into this pretty frequently when we're doing these combustion reactions. I call this the odd-even problem. And the trick to balancing the reaction when you have an odd-even problem is to make the odd side even. Almost always that's going to work. You can never make an even side odd by doubling it or tripling it or quadrupling it, but you can make the odd side even, and that almost always takes care of the problem. To make an even number of oxygens on this side, I'm not going to mess with the coefficient over here for my O2 because that's always going to be even. I'm going to double my odd oxygen, and now I will have an even number of oxygens. But before I balance the oxygens, because they are the most difficult to balance, notice that putting the 2 here messed up my carbons and my hydrogens. So before I get back to my oxygens, let me fix my carbons and my hydrogens. In order to balance the carbons, I need a 2 here. In order to balance the hydrogens, I have 4 hydrogens in each molecule, but I've got 2 molecules. Do you see the 8 hydrogens? And to make the 8 over here, I need a 4 coefficient. Now let me balance my oxygens. 2 times 2 is 4 plus another 4. I have 8 oxygens on the right. Right now I have 2 oxygens plus another 2. I only have 4 oxygens on the left. Do you see how we can make 8 oxygens over here without messing up the carbons and the hydrogens again? That's very important. If we can keep from messing those up again, we want to. Do you see that if I add 3 O2s, that would be these 2 oxygens plus another 6. Now I would have my 8 oxygens. So this balances the reaction.